last topic of the day, the arrays. Again, you know what arrays are if you used any normal language and you're a normal developer. If you're not, maybe not. So array is a sequence of elements. Like in normal languages, arrays usually contain certain type of elements, like integers or strings. In JavaScript, of course, everything is more complicated because it allows you to do pretty much anything you want. So arrays can contain all kinds of stuff. And arrays are basically represented as objects in JavaScript, and they have their own prototypes and functions and methods that you can use. You can iterate through them. You can change their sizes. You can get properties like length and I think others too. So an array would contain a number of elements, usually a known number. And you can address each element by their index. So we have 5 elements in this array. So the first point of index is number 0, and the last one is number 4. So it's 0-based counting. Declaring arrays, you don't need to declare anything. You could use the array constructor. I think we'll see that also later. But basically, what you can do in order to declare an array is just create a variable and then assign it to an array. It can even be a completely empty array, just putting the square brackets. And you can immediately fill it with information if you have this information. Down here, we can see an array of arrays. So you can also, each element in your array can be an array in itself, if you really like such stuff, you perverts. The second example, by the way, is also interesting. Like I mentioned, there's no rules and there's no one to stop you from making an array, where the first element is number, the second array is a date object, and the third is a string hello. So it's legal, but it should be illegal. And again, one more anecdote here is that you see that the second example doesn't have a semicolon. Again, what can I say? Declaring and initializing arrays. The second example, we can also use the array initializer object. So you can do a new array. Notice that array is with uppercase A, either with elements or just initializing the size of the array without putting any values into it, or just like we saw in the previous slide, just initialize it directly with elements with brackets. You don't need the constructor and you don't need to put anything into it. One of the functions that array gives us, we'll run into it later, is the join function. It actually takes all the elements into in the array, casts them into a string, and put them into one long string with concatenated delimiter. So in this case, we're joining with this string, so we'll have all the elements in the array delimited by comma space. So in this case, we're initializing this array with the 5 numbers from 1 to 5, and we'll get all the elements in the array and print them out in one call here to array.join with a comma. So we'll have all the numbers in the array in a comma. Here we have an empty array of 10 elements, and again we can join and see how they represent as strings. And here we can see that we're addressing the array object number 2, which actually is number 3, so in index 2, and printing it out specifically. Here we have an initialization of an array of the days of the week. Excuse me of that. Yeah. So again, initialized with an array of strings, and again we can join them up and see how they look in concatenated as a string. And here we have the crazy array of number, date, and string, and again joining them and seeing what they look like. Okay. So the first array with numbers concatenated like this. The second array, which actually is empty, will concatenate as empty strings, but when we try to address a specific element in it directly, we'll get undefined because the value is never been filled. So notice these two differences here. This is the array of the days of the week, and this is the array with number. This is the date object actually being casted to a string. So this is the default output when the date object is actually not being formatted at all, but you can format your date time strings. So all the information is now casted here as this long representation string of the date time of the current object and the string hello. So these are all one array, and they are delimited by commas. Accessing the elements in the array, like I mentioned, doing it with a square brackets operator, which gets an indexer, which means we have to specify the index in the array range from 0 to length -1. So if it's an array of 5 elements, we have to go from 0 to 4. Otherwise, we'll have an index out of range, and we'll get an undefined, I think, unless we get a JavaScript error. I think it will get undefined. Yeah. So also, if you need to change an array, an object in the array, you address it by the same square brackets. So an example, again, the array of 5 integers from 1 to 5. It's a bit confusing because the first index is actually 0, but it's containing the number 1. And if we get here the array.length, we'll get the length of the array, which is actually 5 elements. Here we are creating another array called reversed, and we're just initializing it with the same length. So now we have 2 arrays with 5 elements each, but this one is uninitialized. And then we're going here in a for loop and counting from 0 to the length, which means to 5, but actually we'll get out of the loop when the number reaches 5. We will not go into it anymore. And increment. And what we're doing is we're putting the array at the index. So the first one will be put at length.index. We're filling the reversed array from the last element to the first element. So we're scanning the first array from 0 to, I have to do it the reverse way, from 0 to 4. And the other one, we're actually filling from 4 to 0. So we're actually reversing the array. This demo, by the way, I think there's also a method that reverses it that we might see later. So exactly as seen on the slide, we're going here. Maybe we better see it in action. OK, that was too fast. Just to see what happens in the code. OK, so I'm reloading the page to see what happens in the code. So here's the first array gets initialized. So this is what it's represented by. We have the indexer from 0 to 4 and the length of 5, and a few other prototype methods and supported properties. Then we have the length. In our case, it's 5 because we have 5 elements. Then we have the reversed array that we are initializing with 5, but actually it's initialized with no objects, just the size. And then we're running on the index as a loop counter here for the for loop. So the first iteration, we are now at 0. So we're going to fill length minus index minus 1. So we're going to start at place number 4. This evaluates as 4. And we're going to fill the reversed array at the place 4 and what we have in the array at place 0. And iterate, iterate. We can see how it gets filled. Now, it's like this. And now our array of our reversed array looks like this. And we write the array and reversed to the console with a join function, and that's it. How cool is that? Not very cool. So one very common way to go through arrays, usually you would go and, since arrays are serial objects, and the whole idea is that you have elements in separate indexes. In other languages where you have some law and orders, you can also know what size of each element is, and you can find your way in the array if you know to find a pointer in memory and go to the right place, if you can calculate the size of the pointer. And in JavaScript, you have to go through the indexes. Here, you can access every array element only by their index. And one way to iterate through is with a for loop, like we saw just now. So this example goes again in a for loop, goes with the index from 0 to the array.length, means -1 in practice, and incrementing every time. We're filling another array called squares, which has the same length as the other array, because we have to fill all the indexes here, and we're just calculating what's stored in array in this index and multiplied by itself. So we get the squares into the other array. It's crazy stuff. Again, some crazy stuff. These people are out of their minds. So we have an array here, which we are scanning. Again, but we're scanning it in reverse. So we are starting with array.length, but array.length is the length of the array again. So if we want to start at the last element, we have to go to array.length -1. Otherwise, we're out of range. And we're counting until our counter reaches equals to 0. So when it's 0, we're still going into the loop. And we're decrementing every time, and we're printing out to the console what's stored in the array in the location indexed I. And this loop, again, scans the array from 0 to the last element, incrementing, and putting the index number that the counter actually in every place in the array. It's very straightforward, right? Also, pretty much like we saw earlier with objects and other complex entities, you can use for in order to go through the arrays. The indexers will be given to you, and then you can use them in order to address elements in the array. So pretty much like we did here, just we're getting the indexers one by one, and we're getting them as pretty much as a property. We'll see maybe a more complex example of this also later. Not much later, but a bit later. Here it is. So here we have an array of strings. It gets initialized. You can see that it's nicely laid out in a readable way, so that you don't have to put actually everything in one line. White spaces are still okay, and this indentation is okay. So we are initializing this array with strings, and then we're running through with for I in this array, and we're printing array in this indexer here, which is given to us through the iterations. Let's see. Okay, so again, just running through the arrays, just this time with for in, and every time writing to the console what we have in the capitals array in this iteration location. So I will give us every time the indexer of this array from 0 to the last. We don't need to build a counter and increment it every time. And this yeah. Yeah, it will iterate. it will just be, the value will be undefined, but the iterator will go through it. Yeah, it won't work in this example because if I omit one of those, it will make a shorter array. And if I remove something in the middle, it will also get a shorter array. But if it, in any case, you're getting into one of those, you can try to do it like this, maybe, var a. But a is uninitialized and undefined. And you can put it maybe here. So it's evaluating it as empty string, but let me see it again. Great. Here. And let me put watch. Yeah, we can put I, and we can put so we can see what it evaluates to. Actually, maybe it's because the array has strings. No, here it is, undefined. Okay, so in place number 2, our value is undefined, but we can still print it out, and probably this casts this value to a string, and that's why it goes up to the console as empty. But then we continue to the next element, and we see that it goes through. But this is actually evaluated as undefined, but it doesn't break your loop, because the loop variable is just your iterator. No. Okay. JavaScript is also very permissive when it comes to the size of the array. You can very easily increment it at runtime. You can push element into it from both sides. You can pop them out from both sides. The size basically can change at runtime. So there are these valuable functions. If you have an array element, or basically an array variable, you can use push to push an element into the array. This will push it to the end of the array. And then you can pop it also from the end. That gives you, yeah, it gives you the implementation of a, well, it's not a queue and it's not a stack, because you'll have to combine those to have one implementation. But basically, the last element of the array can be pushed or popped. And then we have the shift method and unshift. So these do the same thing, but from the other side of the array. So you can push things to the beginning of the array with unshift, and you can pop them up from the pop them out of the beginning of the array with shift. Okay, I think it's better if we just see the sample, because just not to repeat the explanations twice. Okay, again, our crazy array of numbers from 1 to 5, and we're just typing out the what's up every time with this delimiter of vertical pipe. So pop and push would take out elements from the array, from the end of the array. Actually, I think there is something missing. Okay, so in this case, we're popping out the last element of the array and taking the value and putting it into this variable, and actually the array will become smaller. Something is missing here. I think this should be here. And this should be here. that's better. So we're popping out the last element in the array. We'll see what's removed. Then we're pushing another number 0 at the end of the array with the function push. Then we'll reprint the array. It shouldn't be like this. It should be like this. And then we're doing the same thing with shift and unshift. So we're unshifting. That means we're inserting an element, but this time from the other side. So basically, it will be expected to be like this. And then shifting, taking out the head of the array, so we'll get back to this structure. I hope I'm not messing it up. So we removed the element in the end. Then we pushed 0. Then we're inserting 0 also in the beginning, and then we're removing it again. So you can play with arrays. You can create effects of stack and queue by pushing and popping elements from either side. And just to show that they're completely dynamic. So if we get in the console something like, so an array can start completely with nothing. What the hell happened? Yeah, this would return an undefined, but actually because there's no value to this expression. But X is now an empty array, and you can see that it is an array with 0 elements. And you can completely dynamically start working with it. So we got 1 as the number of elements, and now it will look like this. And we can push another element into it to the end of it. Now we have 2 elements in the array, and it would look like this. Sorting. So this is tricky a bit. So sorting usually would also try to cast the elements in the array by default as strings and sort them. It's not called alphabetically. It's called lexicographically, I think. So if you have an array of numbers like here, that will be okay because the numbers are small and you can sort them and they still correspond to their string representation. So if I want to print this array, it will look nice. But if I have an array like this, for example, I can call the array function sort, and by default the elements will be sorted as their string representation, and what we'll get when we try to print this array is 2 and then comes 23, because alphabetically 23 comes after 2 because they start with the same letter, and then we get 4 and 5. So it is sorted. It's not true what it says here that it's not. It's just not intuitively sorted for us. So there's a way to get over this. You can have your own comparison function, and you can build your own logic of how you want to sort your arrays. For example, here is a method that order by. The name is, of course, arbitrary completely, but it should return 0 if the elements are equal. It should return 1 if the first element is greater, and otherwise it should return -1. This is the most smallest way for having a condition in one statement. So once we have an array like this, we can call sort, and we can supply which function will be used for evaluating each of the 2 elements in the array to define, to actually understand which of them is greater than the other. It works like this also in other languages. You could build your own comparison functions and use them for sorting elements. So once we have this, actually our array will be sorted according to our logic, which is defined in this function, this comparison function. It's a very sad picture. Okay, so again, the same example. We have this array of numbers. If we call sort first without providing any comparison function, then they'll get sorted by their alphabetical textual order, which means that 23 will come after 2, and then 4, 5. But if we supply our sort function, which gets the comparison done here, yeah, that also pretty works because it will return the right values. If A and B are equal, it will be 0. If A is greater, it will be a positive value. And if B is bigger, it will be a negative value. So this will also be OK to use it like that. And once we sort, we actually invoke our own sort method. So that should also be OK. So this is the sort without providing any function, and this is the sort with our function. Other functions which help us working with arrays, we already saw the join function that concatenates all the elements with a string separator and gives us a string of all our array elements. Concat will insert the elements in the array at the end of the array, just like push would do them, but here we can have a number of elements. I think it could even work with another array, so you can actually take two arrays and combine them into a bigger one. Reverse, which would reverse the elements according to their sort order, but not according to the sort order. Just take the array and reverse the orders of the elements in the array. And splice, which is a more complex method. It goes to the array to where you put your index. That's the first argument. Deletes the number of arguments that you specify here and puts in new elements instead. So I'll show you how it works. It's a useful function, but it's tricky because it can do a lot of things at one time. And you can do it at the end of the array, at the beginning. You can do it in the middle of the array. It's really useful. It's like a Swiss knife array function. You can have a filter to filter out elements in the array which don't fit a certain logical condition. Or you can run a for each, which actually allows you to iterate through the array elements in the context of an anonymous function here. So you can run your functionality iterating through the array, just like we saw with loops, but with this alternative notation. Okay, let's see what we got here. So the numbers array, and we have a reversed array that we just call the reverse method that will just create another array with the same size but reversed order of elements. I don't know why they had to hard code this, but I would probably do it like that. That's better. And here we are iterating with for each on each of the elements and printing them out instead of doing a join, just to demonstrate that you can actually do it with this type of notation. Then, well, again, what we're doing here, we are taking another array and we're concatenating all the elements into the original array. So you can just join two arrays like this. Then the splice. So the splice here says, start from 0 element, take out 2 elements, or actually, yeah, I think 2 elements out of the array, and replace them with these 3 elements. So this all happens in one call. this will return the elements that actually were extracted from the array, so you can reuse them if you want. Then we're printing out the deleted part, which was here returned, and the new array as it is now. Here we're pushing new numbers into the array, and now we're applying a filter here. So the filter is also a function that would follow the logic returned by this. So if this one would evaluate to true, this function will return the true value, then the number will be printed out. So it should be printing out only elements that are even numbers. Okay, it's a little bit complex all in one. Okay, so this is the reverse function that took this array and reversed it, so the numbers are now in reverse order. It looks like they're sorted in reverse, but they're just reversed. Then we're concatenating another array, so we're taking this and adding it to this, and we're getting, I think some things are hard-coded and they're wrong. Yeah, that's not right. Let me just change this with that, so actually at least the logging will be correct. So at least we'll be able to see what's really happening. And this again will give us the wrong result, but I'll show you the splice in a normal way. So concatenation now actually shows what we have. This is the array. We're concatenating with this array, and we're getting them in sequential order. And then we have the splicing and actually the filtering. The filtering really works. You take the array and we filter, and this was our condition function. So we're getting only the even numbers. And the splicing, I'll just show it to you here in the console because it's easier. So suppose we have an array which evaluates to these elements. So now it looks like this. And I can do a call splice. And let's say I want to start from object number, the third object, which is this, because we're going by 0 index, and take out 3 elements, and put instead of those the number 3, 4, 5. So the return value of this call will be the elements that we are throwing out of the array, and they'll be replaced by these. So this is what we took out, and our array now looks like this. And you can play with it. You don't have to put anything back. I can do a splice again and take out let's say 2 elements, and I'm not putting anything back. This is what we took out, and now the array looks like this. So this is a handy function if you want to take things out or you want to put things in. I can also put things in but not take anything out. So I can put 0. So nothing came out, but the array now looks like this. So cool stuff. Okay, other useful functions. If the element found in to find elements in the array, actually you can find them by index of or last index of. This works also for strings. We'll see it when we talk about strings the next time. Yeah, doesn't work in all browsers. I'm not sure which ones support it and which don't. Personally, I haven't seen a lot of index of and last index of used in arrays of complex objects, but these functions do exist regardless of their support. So as a demo, we have this array again of numbers, and we're trying to find these two, one that exists in the array and one that doesn't exist in the array. And if it's found, it gives you the index. If it's not found, it gives you -1. I just wonder if this will work. Probably it will work. Yeah. And this? Is this even existing? Okay. It's good news. The last index of has issues? Let's try. That still works. Still works. I don't know how I have Internet Explorer. Still works. Wait a minute. Okay, we lost the page. Yeah, it doesn't support divs anymore. Doesn't support JavaScript. Okay, great. Okay, so just to mention these two, so we looked at type of when we talked about data types. So arrays, like I mentioned, are basically just objects in the language. So if you check the type of, it will return object. But there's also a function called isArray, which is of the prototype of the array type, which is like I mentioned, we can initialize an array with a new array, with the array with the uppercase A. This is the data type, actually the class name, let's say, of array. So you can call this, let's call it static function isArray, and you can pass an object to it, and if it is an array, it will return true. Otherwise, an array is treated just like a standard JavaScript object, and when you check type of, it will say it's an object. So there's this link. I'm not sure why specifically, but I think that I've also put here. Yeah, so these two links are valuable if you want to dive into more stuff about, basically about everything we're talking about. So there's the Mozilla Developer Network. There's a lot of official JavaScript documentation, and also the W3C schools that have reference to pretty much everything web-based you want. So there are debates about this site, if it's good or bad. Some people say it's misleading and it's not the best efficient documentation site, and that it has some things, but people take it as the Bible, and many times it's almost like Stack Overflow. They go there and they find stuff and they copy paste, and there's a lot of examples. I think it's very useful. It has everything you need to know about all the standards of front-end HTML, CSS, JavaScript, and whatever you need to know, or examples, or to learn, or to get into some references and get information. You can get it from the W3 schools or from the Mozilla Dev Network. And the last thing I want to mention, again, shameless self-promotion. So I just want to show, I got it. About JavaScript. First of all, I mentioned last time about this bookmarklets and their structure, which is called the self-contained anonymous auto-executing function, or in short, YIFI, which I forgot what the abbreviation. Maybe I actually wrote it here. Okay. Yiffy, yeah. Immediately invoked function expression. Okay, so that's why it is. This structure here that I showed you last time with bookmarklets. And this guy called Douglas Crockford, and there's a very small excerpt from one of his lectures. He is one of the founders of JavaScript and one of the best lecturers about the language. And here I have some posts which I stacked a few of his most basic JavaScript lectures. They're, I think, very interesting. If you want to deep dive or you want to understand how things work or why they work like this, I think that anybody who has any interest in JavaScript should watch these lectures. So they're not really telling you the theory like we're doing now. We're diving into the building blocks of the language, but he's going much deeper into how things were decided and how they were made and why they were made the same way. And there are a few lectures here about different topics, about the history of the JavaScript, about the ECMAScript, which as I explained is the standard name of JavaScript, and how things really got to work the way they were. So if you want to get into some interesting, deeper diving understanding lectures, I warmly recommend to check out these lectures. They're quite amazing. So much for resources. And that's it for now. All right, thank you guys.